Your PhD student? Third year PhD student?
Second year.
Second year?
Yeah.
But she's teaching for a third time. ABAQUS.
Many times.
Many times. Okay.
So,
But,
fifth time, yeah.
okay. Anyway, she will give 6 or I don't know how many lectures. There will be 2 lectures today and Friday. And there is a homework, they call homework, I call project. It's due on February 7th.
Yeah.
And then there's a recitation. I don't know what you do in the recitation hour. You have recitation on next Tuesday.
Last Tuesday.
What hall is that? LIE, some hall.
I don't know.
You don't know, okay. It is all posted in the syllabus. Today I just posted. There's a recitation at 5th period. What do you do in the recitation?
Homework problem.
The problem, you will show how to do it.
Yeah. So basically the recitation is for solving your homework help you. So
Homework means project. We don't use the word homework.
okay, project problem. Yeah.
Okay, let me finish and then you can take
Okay,
over.
yeah.
And then she has office hours, several hours, and her office is in MAE A building, 333.
Yeah.
Okay, with that I hand over to TingDong. If you have any question, please don't come to my office. I know anything.
Okay. Okay. Sure. So for the project, my suggestion is that start early. Don't wait until the deadline, the night before deadline, and then keep sending me email. I cannot fix your problem by email at that time. So start early and bring the question to the recitation class, and also bring the question to my office hour. And for the ABAQUS problem, it's hard to explain by email, because if you get stuck somewhere or you have some bugs, it's really hard to explain through email. So I highly recommend come to my recitation and come to my office hour for your problems and start early. And today I will give a basic introduction of the ABAQUS. So this is a basics. First, we do everything on the graphical user interface on the ABAQUS. It's like you sketch your geometry, you define your multi-property, and apply the boundary condition and apply those. So after this is done, and when you submit your job or create input database, the input file will generate it. And this input file is a programming language that interacts with the ABAQUS. So it's a language that ABAQUS can understand. So all the information you give in the graphical interface will be stored in this input file. And then using this information, ABAQUS will build the matrix and solving the matrix and solving the problem. And the result will be showed generated in the job ODB. ODB means output database. And this is and then the post processing is simply that put this information in the output database and interpret it into the graphic interface, and then you can see the displacement and you can see the contour plot of the stress or any result that you want to see. So this is the basic procedure in the ABAQUS, and there are 3 methods of doing this ABAQUS analysis. The simplest one is the interactive mode. So you define everything in the graphic interface, which I will do today. And then you will check the result also in this graphic interface. So this is only for simple cases, but when you go to the industry and if you need to do some like optimization problem or your problem is like a very big system, it's better to use a Python script or Amplify. And the only problem is that to use this Python script or Amplify, you need to understand these 2 languages, and also you need to know how to use them. And in my second tutorial, I will talk about this Amplify and how to modify the Amplify to modify your model to change your to your analysis. This is the components in ABAQUS model. As I said, first we need to sketch geometry, and then discretize this your model to small elements and define the section property, material property, a moment measure, something like that. And then I define material data. And then I apply loads and boundary condition and define what the analysis type is, linear, nonlinear, or static and dynamic problem. And then I define what is the output request. Do you need to want to know the displacement result or stress result or section force, section moment, something like that. So you define everything in ABAQUS model, and then they will do the work. So for example, this is a model that we want to do we want to analyze, and this is the model. And if you want to know the stress or displacement at any point on this model, it's hard to calculate directly. So what do we do? That we discretize it to element, and then for stress we can calculate the stress at each integration point, and if you want to know the displacement result, we can calculate the displacement result at each node. And then for the area in between, we can do the interpolation. So as this discretization and interpolation are just a approximation, so it cannot give you accurate result. And if you want to increase this accuracy, we can use smaller elements. Use more large number of elements. So this is the basic meaning of this FEM modeling. And this is the most typical problem in FEA. So this is a cantilever beam, and on this side is clamped. And on the upper surface, you have pressure applied on the upper surface. And we have two different types. We can use different type of element, two different type of element to model this problem. One, we can use beam element and use this and apply the pressure on each node, or we can use solid element, which from the geometry is exact same look like this cantilever beam, and also apply pressure on the loads. So my question is that, do you have a question?
Yeah, I was just going to say, is it each node is that pressure, because it's like a point, it's not an area, so is it like, how is that defined like this?
Yeah, you will learn that in your later FEA class. So for FEA problem, you cannot just apply pressure at everywhere. All the force, pressure or concentrated force or everything, you need to discretize at each node. Force can only apply at nodes. And so my question is that for these two different types, which element type will give you more accurate results? Solid element. So you agree with that? Okay, so the answer is beam element. Probably it's hard to understand now, but hopefully later in this semester, after you learn what is a beam element, what is solid element, and the capability of beam element and solid element, you will know that beam element will give you much higher accuracy result than the solid element. So what I want to say is here, is that for the operation on this ABAQUS, how to do it, how to model it, and how to do everything on the graphic interface, they are simple. The difficult part is that you need to understand your own problem. So you need to understand your problem, your boundary condition, your loading condition, and also you need to understand the capability of each element type. So when you go to the industry, when you face a problem, you need to make a decision what element type you should use, based on your understanding of the problem, based on your understanding of ABAQUS. And also, when ABAQUS gives you a result, you need to understand if this result makes sense or not. ABAQUS not always give you accurate result, it's just a program, so it can calculate everything faster than you, but sometimes it gives unreasonable result, and you need to know whether it makes sense or not. And also, when a element type is capable of represent your problem, one element is accurate enough. It's not the more the better. And this can save you a lot of the computational time. But if your element type does not have capability to represent your problem, you need to do the approximation. And in this case, is the more elements, the better. But the problem is that you need to also consider about your computational cost. You cannot run every problem like for 20 hours. Also, you need to consider the accuracy requirement of your problem. So combine all this, then you determine how many elements do you want to use in your problem. So this is the start, a basic window, start window. So I will show it here. This is model tree and toolbox and the main menu here. And the problem we're going to do today is a very simple, well, it cannot move. Okay. Overhead hoist. This is, so this is the example we're going to do today. And these are 7 trusses, and the length of each truss is 1 meter. And material property, density, Young's modulus, and Poisson ratio. And the dimension of this truss is 5 millimeter diameter circular. And a pin joint. The boundary condition here is a pin joint, right? So it means it fixed in x direction and the y direction. The translation degree for them is fixed in x direction and y direction, but it can rotate, right? And on this side is a roller support. It means that it cannot move in y direction, but it's free to move in x direction, right? And loading condition, I apply 10,000 Newton concentrated force here at this node. So let's see how to do it on ABAQUS. It's not moving. Okay. First, we create parts. So for this model tree, we can just follow this step one by one. But for our simple case, we can skip most of the steps. First, we create part, double-click part, and for our problem, it's a 2D problem and deformable. We use wire for this truss problem. So for truss and beam problem, we use wire. And in later tutorial, when we use the solid element, we use shell. So this approximate size is the approximate size of this sketcher. So because the dimension of the truss is 1 meter for each truss, we can just use general like 6, or you can use any number you want. It doesn't matter. So it's just a approximate size for this whole area. Continue. So there are different ways to do the sketch. You can just sketch directly here, or you can enter the XY coordinates here. So for the problem today, I will use this one.
So the approximate size is in meters?
Sorry, what?
The approximate size is in meters?
Okay, the unit, sorry, I forgot. Unit is very important in ABAQUS analysis. So for ABAQUS, there's no built-in unit. So what you need to do is that it's your responsibility to make your unit consistent in the whole analysis. So for example, if I use 6, it means that the length is meter, right? The unit for length is meter. Okay. But I can also use millimeter. You can use any centimeter as long as you can make it consistent in your whole analysis. So for example, here I use length meter and force Newton. And when I get stress result, it only gives you a value. There's no unit in ABAQUS. So I will know that the stress showed in ABAQUS is Pascal. And if I use millimeter as the length and Newton as force, the result will be megapascal. And in your homework problem, I think there's some trick in there about unit, so you need to be very careful which you need to snatch or, yeah. Always make your unit consistent in your whole analysis. And let me finish this geometry. So this little h here means horizontal. I will put this 9. Now I use this add dimension. You see here, add dimension. I define this one as 1 meter. And then I can keep doing this for all the trusses, or I can use add constraint. And you can see here equal length. So I select all the shift and select all the trusses. Done. So all the trusses have the same, has equal length as 1 meter. So geometry is done. Any question here?
How did you get to the equal length thing?
So we go to the part. Add constraint, and then you probably will use the rest later in your semester, and today I will use the equal length. No problem. Any other question? Okay, so geometry is done. And now I need to define the material property. So here general, we can input the density, but for our problem, because I only want to know the displacement result and stress result, the density is not necessary here. But later, if you need to do some optimization problem, and you need to, for example, you need to minimize the weight in your optimization, you need to input the density to know the weight result. And mechanical, I use the simplest one, elasticity, elastic, and isotropic. And later, if you need to do any like composite problem, you can use other materials. So today, I will only use isotropic. Young's modulus, I think is 200 gigapascal. Poisson ratio 0.3.
So you only added elastic? That was the only-
Yeah, elasticity, and Young's modulus and Poisson ratio. And now we define a section. So section, we choose beam. Truss is another beam category, and truss. Continue. The material one is the material property I just defined. You can change the name. The cross-section area. The cross-section area, as I just said, the diameter is 5 millimeter, right? So I can just calculate here directly. Pi, because I use meter as length, so it's 0.005. 2 star means power, and over 4. So this is a cross-section area I defined. And so the definition of the material property and the section is done. And the one question is that for our truss problem, it only asks the cross-section area of the truss, but it doesn't ask the geometry of your cross-section. Why? Why it doesn't matter? Because if you think about for the beam problem, we need...
Trusses only have an axial load.
Yeah. And?
And then you only need to worry about the cross-sectional area for stress.
Yes, yes. So for truss, we can think that if you want to know, there's only sigma xx, right? And sigma xx, the equation for calculating this sigma xx is f over a. So if we want to know the stress result or displacement result or anything related to the truss problem, we only care about the cross-section area. But for later, on my third tutorial, when we talk about the beam problem, we need to know the cross-section geometry. Either it's circular or box or any other shape. We need to know the exact cross-section geometry and the size of each, the detailed size, because we need to, at that time, we need to know the moment inertia, and to use moment inertia, we need to know the geometry. But for our problem today, cross-section area is good enough. And now, I only define this section property and the material property. I didn't assign this property to this geometry, to a model yet, so I need to main menu assign section, and select region to be assigned a section, I select the whole region. Done. So the section 1 is the section I just defined, and material 1, type truss, okay. And so this assignment is done. Now, next step is to do the assembly. So For our case, there's only one part and one instance. So we need to assembly basically mean that if you have very big system, and for example, if you need to assemble 100 bolts in a car model, and what do you do that? You sketch one bolt and define the material property and define the section and define everything, and then you make this as one instance and then like copy and paste and make it 100 instance. So you can just use this 100 instance to assembly in your big system. So that is the basic meaning of assembly. But in our case today, we only have one part, one instance. We can just create part one. And this dependent and independent mesh on part and mesh on instant, it means that, for example, if I mesh on part, this 100 instance, this 100 bolts will have the same mesh. But if I mesh on instance, I only have this mesh defined on this single instance. But for the rest 99 instance, it can mesh differently. So this is the meaning of dependent and independent mesh on part and mesh on instance. But for our problem today, we only have one part, one instance. It doesn't matter. You can use any one you want. So next, we need to create steps. This is for the analysis type. And for ABAQUS, by default, it is to analyze the nonlinear problem. So for our problem, because it's a linear, we need to change this general to linear perturbation and static linear perturbation. And we can see that after we create a step, the field output request is created automatically, and we can check that. So this basically means that ABAQUS can give you a lot of results: stress, strain, energy, thermal, but you do not need to know all the results, right? So you can control this by select the result that you want in your output database. And by default, it has CF means concentrated force, LE means logarithmic strain, RF means reaction force, S means stress, and U means displacement. So this is the default setting. For our problem today, we don't need to change it because we only need to know the stress result and the displacement results. This is good enough. But for later, if we do the beam problem, we probably need to know the bending moment, and so we need to add the section force and moment in our output request. So we can know the bending moment and the corresponding result in the output database. But for today, we only use default setting. And now let's do the boundary condition. So on the for this problem, we have a pin joint here at this node and the roller support at this node, right? So for the boundary condition, I would change this step to initial and use displacement rotation. Continue. CNet region for boundary condition, I snap this point. And U1, U2, UR3. So in ABAQUS, 1 means X direction, 2 means Y direction, and 3 means Z direction. So this U1, U2 means displacement in X direction and displacement in Y direction. And UR3 means rotational degree freedom about Z axis. So for this node, which degree freedom should I fix?
First two.
First two, okay. So fix U1, U2, and it's free to rotate. And then create another one, initial, displacement rotation, and isolate this node. Which one do I fix? U2. So boundary condition is done, and now let's apply those. Double click. For the loads, we change this step to step 1. And because the loading condition today is concentrated force, I use concentrated force.
Why didn't you fix UR3 for the second node?
Sorry, what?
Why didn't you fix UR3 for that second node?
This one?
Yeah, it's not.
It's free to rotate if you think about it. The rotation is free to rotate.
You can't rotate rotate around that point though?
It can rotate.
It's a pin on a rope.
It's free to rotate. You mean at this point, right? So the only fixed degree of freedom is the translational degree of freedom in y direction. All the other degree of freedom are free. Okay, let's go to those. So snap points for the load. CF1, CF2. So this 1, 2, 3 apply to the boundary condition, apply to the loading condition, also the same to the result like. So U1, U2 means displacement in x direction and displacement in y direction. CF1, CF2 means concentrated force in x direction and concentrated force in y direction. And later in your result, because for truss problem we need to know the sigma x's. So in ABAQUS, it will give you as S11. So this 11 means XX. So for our loading condition, what I should put here? And here? Yeah, negative 10,000 Newton. And so all these are done. Next step is to do the mesh.
So does it assume pin joints at all the other joints then?
All the other joints you do not need to do anything. So when you collect sketch geometry like this, these are by default are pin joint. Okay. Yeah. Mesh. First, we need to define mesh element type. You can see the information here. Select region to be assigned element type. I select whole region. And because when I define our problem as 2D wire, by default ABAQUS see it as a beam problem. But because our problem is a truss problem, we need to change this default setting. And also we have the option of linear and quadratic. And today we only use linear problem. And you can see here the element type is T2D2. So T2D2 means 2-node, 2-dimensional truss. Okay. And now we can do the seeding. So seeding is based how we discretize this model. We can either seeding instance or seeding edges. So this approximately global size 0.1. This is a default setting. It means that the element length is 0.1 meter. So for one truss, we have 10 elements, right? But for truss problem, we need to remember that for one truss, we can only have one element. Because, for example, if you have two elements on one truss, if you apply tension, it works fine. But if you apply compression, the center node will work as a hinge. It will collapse. So always remember for the truss problem, use one element for one truss. So if we use this one, we need to change this to 1, right? Because length of our truss is 1. Or we can...
So it's treated as a rigid system?
Sorry, what?
You're saying so it's treated as a rigid system where the beams can't collapse?
This is a truss problem. It's not beam problem. So for beam problem, you can see it as many elements as you want. But for truss problem, only one element for one truss. Otherwise, if you have a node at the middle of the truss, if you apply compression, your truss will collapse. Yeah. Where am I? Okay. So I just use seed instance. Also, you can use seed edges. CNET region to be assigned local seeds. I select whole region. It's the same. So for truss, I can use by number. So for number of elements, it means that if I use 1, it means 1 element on each truss. If I use 4, it means 4 elements on one truss. And in our problem, because all the truss have the dimension of 1 meter, so if I use approximate size 1 meter, it's directly one element on one truss. But if you have a geometry that have different length for each truss, you can use this one. So it means that no matter what the length of each truss, I use one element on one truss. So this is another way to do the seating. And after define the element, mesh element type and the seating, we can do mesh, main mesh instance. And okay to match the part instance, yes. So the mesh is done. And you can see here, 7 elements have been generated on this part 1. And also, we can go to main menu view, assembly display option, mesh, show node labels and show element labels. So you can see here, this purple one is a node label, and this little number here is the element label. So when you get the result from the ABAQUS, for example, in your output report, it shows that displacement at node 1 is displacement at node 2 is, or the stress result of element 1, element 2. You need to know which element or which node they are talking about. And this label is different from the problem that I gave in the homework. So you need to be very, very careful in your report which element or which node you are talking about. So mesh is done. Now let's go to, we can create a job. Double click. You can change the name here, but I'll just skip it. So we created job 1, right click. You can see here there are a lot of options. So data check is for very complicated system, it's very easy to make some mistake. And so data check is that ABAQUS will not solve the problem, but they will build a matrix and to check if you give any wrong information in your model. So for complicated situation, you can use data check first and to check if you have something wrong there. And monitor is also for the complicated situation. For example, if this analysis need to run for about 10 hours, and in the middle you need to know whether it's stuck somewhere, or you can use a monitor to see where it is. And for today, I will submit directly, so it will solve this problem directly. Completed. Right click, go to results. So this is original geometry, and this is the deformed geometry. And this is a contour plot of deformed geometry. And you can see here, this is von Mises stress. And for truss problem, there's no point to know the von Mises stress. We change this to S11, as I said, sigma xx. And if you think this legend is too small, can change it to okay. So this is the sigma xx result. And if you want to know the contour plot of displacement, you can change this to U. And this is the magnitude, and also you can change this to U1, it's displacement in x direction, and displacement in y direction. So this is one way to check your results. And that in your homework, you are required to report the displacement at each node and the stress of each element. It's kind of hard to get accurate result of the displacement and stress result from this contour plot. So what we can do is that we can use the main menu report, field output, and for the stress value, we use the integration point. So in ABAQUS, the stress is always calculated at integration point, and we select S11. So I want the sigma xx result in the output database apply. So the file output report was appended to ABAQUS RPT. So now let's check the RPT file. too slow. Why it's not moving? Sorry. Okay, it's moving now. Go to C and temp file, and you can see ABAQUS RPT. And check a result here. Scroll down to the very end. Now we have 7 elements, and at each element the stress value is given. So this is the stress result of each element. So what is the value, what is the unit here? What is the stress unit here? Yeah, because we use meter as 9th unit and we use Newton as 4th unit. So here it should be Pascal. And also, if you want to know the displacement result, it's not moving, okay. We can, for displacement, we always need to change this integration point to unique nodal. So it's displacement at each node. And I use spatial displacement and apply, and then go back to the RPT file again. Scroll down. Now we can see that we have 5 nodes, right? And at each node, what is the displacement in x direction and y direction? So this is the accurate result that from the ABAQUS they give you the displacement and stress results, and this is the result that you need to put in your report, your homework report. But don't just copy and paste this one in your report. You need to make a table and list which node you are. Any question?
Before you're saying the integration points, can you show me where? What do you mean by that? What is the integration point?
Integration point, so probably later in your class in this semester, Dr. Senka will teach you the meaning of integration point. So for the Truss problem, I have 1 point, and I use this point to calculate the stress for sigma xs. And for a coordinated element, I don't calculate stress everywhere. I choose 4 points, and then I calculate the stress result at that 4 point. And then for the area in between, I use interpolation. So that is the integration point mean.
So we have one element per truss, and then that element is going to be an integration point somewhere.
Yeah.
Is it usually the geometric center? Where is it?
For Truss, it's a geometry center, yeah. And later, I think it's in chapter 7 or chapter 8, you will know that the location of the integration point for different geometry. And this is the one way to check the result. And there is also, if you want to know the displacement or stress for a specific element or at specific node, you can use tools and query. And for example, here is a contour plot of S11. I can select element. And for example, I want to know the sigma 11, sigma xs at this element. I can select this one. And you can see here, S11 for this element is this result. And also, if I change this to displacement, and I want to know the displacement at this node, you can see this is displacement result. Another thing is that the scale and what is the scale and unscaled mean. So if you think about it, we define this material property as 200 gigapascal, so it's basically steel. And then we apply 10,000 Newton force here. It shouldn't deform like this, right? And this is because ABAQUS magnifies this deformation automatically. We can use this common plot option here, and you can see here auto compute. So it means that ABAQUS automatically magnify this displacement using this factor. So if we choose uniform and I make this scale factor as 1, so it's in real situation, deformation in real situation, we can hardly see any displacement, right? So this is what should happen for if you apply 10,000 Newton force here for your steel structure. So it's for you to easy to see how this deformation goes. So they use this auto compute to magnify this deformation. And this scale and scale mean that we use this unscaled result. It means the deformation in real situation, and scaled means after it magnified. And also we can see, I think we can see it here. Change this to slow down. Can see how this deformation. So you can see that at this node, it's fixed translation different in x and y, and at this node, it's fixed in y direction, but it's free to move in x direction. So this is another way to check your results and see how it moves. Any question?
As far as like negative positive designation for the stress, is positive as in tension?
Yeah. Yes. So positive tension and negative compression. And also one other problem. Okay. I don't know if you have noticed or not. So for the S11 sigma xx, from this contour plot, there's a problem because we should know that the sigma x for each element should be a constant value, right? It shouldn't change within the element. Am I right? But here we can see that this sigma xx gradually change. From this contour plot, you can see that sigma x is not a constant value within your element. This is because the way ABAQUS showed in this contour plot is that they calculate sigma xs for each element, and at this node, the average, this stress result of these 4 elements is cladded and average here. And the same for node here. And between 2 nodes, it uses interpolation, linear interpolation. That's why it showed here that the S11 is gradually change within each element. But in the real result, in the real situation, it should be constant. So anytime if you want to know the accurate result of your stress and your displacement results, you always go to report and fill out a report and get a result there. That's the result you need to put in your homework report. Any question? Okay, so if no question, I think I'm done here. So this tutorial, you should be able to finish the homework 1. And for the second tutorial, you should be able to the homework, problem 1 and problem 2. So problem 1 is for my tutorial 1 and problem 2 is for my tutorial 2. Check the homework problem first, and then if you have any question, you can ask me. I mean, you don't know the ABAQUS? Give me your email address. I will send you another link. Yeah.
If I had issues installing it,